misi guru AYU mencapai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, salam sejahtera dan good evening everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of E-Didik Malaysia and Gap Group Malaysia. So I'm Mr. Peh. Currently I'm teaching at Oleh Tingkatan 6 to Fatimah Melaka. I am the teacher on duty for this week. Okay, so before we start the lesson, I would like to let you know that the e-sigil link for this class will be provided at the end of the lesson. Okay, so please ensure that you complete the link within 30 minutes just after the live finish. And you may use any email to fill up the link. And as mentioned just now, I am Mr. Peh and I'm currently teaching at Oleh Tingkatan 6 Tun Fatimah Melaka. And today we are going to continue our last subtopic of chapter 2, pressure. So a subtopic of today, there will be Bernoulli'S principle, the subtopic of 2.6. And the lesson will be estimate or expected finish within 1 hour. For information also, the physics class of AYU will be conducted 2 lessons every week. So for the Form 4 class, will be held on every Friday, 9:30 p.m. So in this week, the lesson is presented by teacher Linda Nordin with the subtopic of 2.7. Then for the class of Form 5 will be held on today, okay, so Sunday 8:45 p.m. And as mentioned, we are going to continue our last subtopic of chapter 2, 2.6, Bernoulli's principle. Okay, so without further ado, let us start our lesson today. Okay, so in today's lesson, there are 3 learning standards you are going to learn. So this is the first one, which is to describe the effect of fluid velocity on pressure. So we want to see the relationship of the velocity of liquid or gas on the changes of pressure. Okay, so here you can see the situation of the diagram showing the aeroplane able to fly, although they have a heavy mass. And then secondly, so you can see the rising car is able to go through the sharp curve or corner with higher speed, okay, without fall down. Okay, so why these 2 phenomena can happen? Okay, so this is related to the Bernoulli's principle. Okay, so the Bernoulli's principle stated that the pressure of fluid, okay, decreases as the speed of the fluid increases. So the fluid here can be referred to gas or liquid. Okay, so from the Bernoulli's principle, we know that when the speed of fluid increases, the pressure will be decreases. Okay, so the principle is actually very straightforward. Okay, so here will be the discussion. So to generate the idea, to relate the relationship between the velocity and the pressure. So as per mentioned just now, according to the Bernoulli's principle, when the velocity of fluid increases, where here showing as high velocity, okay, so the pressure will be decreases at the region. And there are many reference activity you may see at the textbook. Okay, so at the page of 78 to 79 regarding the activity of 2.13. Okay, so from the activities, there are three activity or experiment you actually can be conducted to show the relationship between the velocity and the pressure when able to meet the Bernoulli principle. Okay, so the first activities will be just using a piece of A4 paper. Okay, so the instruction will be like this: hold the piece of paper, blow air above the paper. Okay, so just like the figure showing here. Okay, so here what you need to see or observe here will be, firstly, you need to describe the motion or movement of paper when air is blown above it. So that means here will be the air flow. Okay, so what will be happen? So you can just look at the GIF here. So when the air is blown above the paper, so you can see the paper is moving upward, or we know as lifted. Okay, so this is the observation where the paper is lifted or pushed upward. Okay, then here the question here we want to relate the velocity together with the changes of pressure. Okay, so here which parts of the paper has a higher speed? Okay, so here as per instruction, so the air will blow above the paper. So the speed definitely will be higher above the paper lah. Okay, the relative speed will be lower at the below parts of the paper. Okay, so the next question here will be, which part of the paper will be has a higher pressure? Okay, so according to Bernoulli principle, so the velocity and pressure will be inversely to each other. So when velocity increases, pressure will be decreases, or vice versa. So that means that we need to see the area where have the lower velocity. So definitely will be below the paper. Okay, so where the velocity is lower, will be creating higher pressure area. So they will be below. Okay, so definitely the lower pressure parts will be at the above paper area because of the flow of air is higher above the paper. So creating lower pressure area lah. Okay, so here will be above. Okay, so because of the difference pressure created upper and lower, where the below the paper area pressure is higher, then the pressure above paper is lower. So this will be creating a net force. Okay, so the net force or resultant force, or here is a lift force. We know as lift force will be moving from higher pressure area to lower pressure area. So that means that the paper will be moving outward due to the resultant force moving outward. Okay, so here mark the direction of the net force adding on paper. So it will be moving upward or lifted. Okay, so the explanation for this phenomenon will be as follows. Okay, so the first, when air is blown across the surface of piece of paper, the paper moving up. So this is what observation we see already just now. And again, I'm showing at the diagram here. Okay, so this happen is because of the air above paper move at the higher velocity. Okay, because we blow the air above the paper, so the velocity will be higher above the paper. Okay, and this will creating lower pressure region. according to Bernoulli's principle. Okay, so here, according to Bernoulli's principle, pressure of moving air decreases as the speed increases. Okay, so the atmospheric pressure which at the bottom of paper is higher. So here the paper is added with atmospheric pressure, which is higher than the pressure above. This will cause the difference in pressure. Oh, just what I mentioned already. So pressure upper or above a paper is lower compared to bottom of paper. So this will creating a resultant force. So the resultant force will be adding outward and push the paper up. And this resultant force we can know as lift force. Okay, lift force. Okay, so we go to the second activity. So where you need to blow air between two balloons. Just follow the figure showing here. Okay, so what happens to the balloons? Okay, so you can see this is a GIF. So the person is blowing between the balloons. So you can see the balloon will be attracting to each other. Okay, so the answer here, both balloons attract to each other. Okay, so again, determine the region which have the highest speed. So definitely, so the air blowing between the balloons will have a higher speed. So between the two balloons, so the balloon spelling will be this. Okay, and then the lower speed will be the air surrounding the balloons. So okay, outside the balloon, so that means will be here, where I draw a star. Okay, so determine the region with higher pressure. So according to Bernoulli's principle, so with higher speed region, they will have lower pressure. So with lower speed region, they will have a higher pressure. So that means the outside the balloon area will have a higher pressure. Then for lower pressure, there will be between two balloons where the air blowing will have a higher speed. Okay, again, the net force will be created or produced because of the different pressure between two regions. Okay, so the net force will be adding from higher pressure region will be at outside balloons area. Okay, to the pressure between the balloon which is lower. So be here. Okay, so you need to draw the arrow. Okay, so the answer, you can just look at the arrow. We'll be adding from higher pressure region, which is outside the balloons, to the region with lower pressure, which is between the two balloons. Okay, so the explanation will be like this. So when air is blown hard through the straw, okay, so here, if I say you follow this figure, we blow by using straw. Okay, so the balloons will move closer to each other. So this is quite similar to the activity we explained just now. Okay, so the air move at a very high velocity between the ball. Here will be balloons now, actually. Okay, so the pressure become low. So the pressure is low because the velocity is higher at the region between the balloons. So according to Bernoulli's principle, the pressure of moving air decreases when the speed of the air increases. Okay, so here you can just look at the figure where labeled with XYZ. Okay, so the atmospheric pressure which act on the balloons will be X and Y here, this region, where it will be outside the balloon region. Okay, so it's higher because the velocity of M is lower compared to region between the balloons. Okay, so here mentioned already, so XY with atmospheric pressure is greater than the pressure at the Z, which is between the balloons, and this will creating the difference in pressure. Okay, so the center pressure will be lower lah, compared to S and Y. Okay, so a resultant force is produced and pushes the balloons to move closer to each other. You can just look at the arrow here. Okay. Okay, then the third activity in the activity 2.3 will be using the Venturi tube. Okay, so the Venturi tube, here we are going to discuss two conditions. So the first, the flow of fluid will be through a uniform tube. Okay, so what means by this? Okay, so you can just observe the figure here, this figure. Okay, so where the water will be the fluid we discussed in this figure. So initially, okay, so the both side of tube is closed. So that means the water is not moving. So you can see the water level is the same at the beginning. Okay, so here the uniform tube, that means we're referring to the diameter of the tube with the horizontal position will be this. This will be vertical tube. Okay, so this will be the vertical tube, and this will be the horizontal tube. Okay, so the uniform tube referring to the horizontal. So when the water will be flow. Okay, so when we allow the water to flow. Okay, so we open, okay, the cover of the tube. Okay, so now the water will be flowing in this direction. So from P to Q, so the PQR position is actually referring to here, P, Q, and R. So you can see at these 3 points, the diameter of the tube is the same. Okay, so the velocity of water will be increases from P to Q. P, Q, R will be here. So the velocity of P and to R will be start to increases. So that means the velocity at the R will be highest. Okay, so when the speed increases, that means the water pressure at point R here will be the lowest. So what you should observe? So you can observe the level of water will be the lowest compared to others. Okay, so the speed of point P will be the slower, so the pressure will be the highest. So you can see the water level will be highest lah at the P compared to Q and R. Okay, so let us discuss the detail. Okay, so the pressure of the water decreases uniformly from P to Q, as per mentioned just now already lah. So that means the speed R greater than Q, Q will be greater than P. So the pressure of R will be the smallest compared to Q, compared to P. So P will be the highest. Okay, so this will be the water level you should observe through these activities. Okay, so here P at this point will be have the lowest velocity, then pressure will be the highest, and showing the level of water is highest. Then Q will be moderate speed and moderate pressure. Then the R point here, so the velocity will be the highest, so the pressure will be the lowest according to Bernoulli's principle. So the activity, this activity also able to prove the Bernoulli's principle. Okay, so next there will be the air. So the fluid here referring to water and the air. Okay, so you can see here now we want to observe the flowing of air. Okay, so what is the observation? So again, so the air will be flowing, increases speed from P to R. So that means point P, the velocity will be lower. Then the R velocity will be higher because the velocity of air will be increases from P to R, just like what happened we discussed at water. Okay, so the pressure at P will be highest. Then the pressure at R will be lower. So here will be the air pressure. So air pressure lower. So the height or H here will be lower compared to the H for P here. So we expected the level of water will be this. Okay, so here we want to observe the pressure of air. So the pressure of air will be lowest, so showing the H at the air region will be smallest. Then the air pressure will be highest at point P, so you can see the HP length will be highest. Okay, or in another way, you can see the water level for P tube will be the lowest because when high air pressure, so the air pressure will be against the water to entering the tube. Okay, so let us see the detailed discussion. Okay, so here the velocity of air will be increases from P to R. So just like I mentioned to you already, the air pressure at P will be the slowest compared to Q compared to R. So here again we refer to point at the horizontal tube. Okay, so the pressure of air will be decreases from P to Q. So that means the P will be have the highest air pressure compared to Q, compared to R. Okay, so lower velocity, there will be higher pressure. Okay, so the lower air pressure at R, so will be a lot more water to entering. This is another way to explain the level of water. Okay, but you can actually just draw the level of air where represented by the H here I mentioned just now. Okay, so the water level, you will see like this. Okay, so here again at R, the velocity is the highest, so the air pressure at R will be smallest. you can just look at the level of H from the air. So, or another way, the water level will be highest lah, because the lower pressure will be a lot more water to rise. While at the point P, where the speed of air is smallest, then the pressure will be highest. This will against the entering of water and showing the water level is the lowest lah among another tube. Okay, so for the second observation, there will be the experiment through the non-uniform tube. So the non-uniform tube here will be referring to, okay, so you can look at this diagram. So you can see the tube here, the diameter will be different. Okay, so this is what I mentioned just now. This will be considered as the horizontal tube. Okay, we're referring to horizontal tube, not the vertical tube. The vertical tube will be no impact. Okay, so we want to see the flowing fluid speed through the non-uniform tube on the pressure. Okay, so here you can see, okay, so the tube at point Q here is actually the narrowest. So when the tube is narrowest, that means the speed will be the highest compared to the wider tube here. You can see these two sides, the P point will be here, so the R will be here. Okay, so the P and R have a wider diameter, so the speed will be slower. So when the speed at the Q, which is the narrowest, they will have a lowest pressure. So the lowest pressure, they will be showing the water level is the lowest lah, compared to P and Q. Okay, and then for P and R, how we can compare the pressure? So you can see P will be from bigger diameter region to smaller diameter. Then for point R, there will be smaller diameter to bigger diameter. So you can imagine, if I say there is many car in the narrow routes go to the wider route, so the car can be speed up. So that means here, if we compare speed of R and P, definitely the speed, the R will be higher compared to P. So that means P will have the slower speed compared to R. Definitely the Q will be highest. Okay, so when the speed at the point P is lowest, that means the pressure P, here referring to the pressure of water. Okay, so will be the highest. So will have the highest level lah. Then the R will be in between P and Q, will be at middle. Okay, so now let us go to the detail of discussion. Okay, so as we mentioned, the middle part of Q has the narrowest diameter, will be here, compared to P and R. Q will be here. Okay, so the velocity of Q will be the highest, just how I mentioned to you already. Okay, so the water pressure will be the lowest. So here, velocity Q will be the highest. So the pressure Q will be the lowest lah. So will have a lower level water. Okay, so here highest velocity, lower pressure. Okay, so we can mark first the level of water which must be the lower amongst another tube lah. Okay, so here just how I mentioned to you, when the fluid is from larger diameter to smaller diameter, so here will be at point P. Okay, so the fluid speed will be decreases because you can see just now I explained to you. Okay, so here if I say there is a lot of car from the wider route. So when go to narrow route, so they must be slow down the speed, right? So the speed at P will be the lowest. So the pressure will be the highest lah. Okay, so here will be lower pressure, a lower velocity, higher pressure. So R will be in between. Okay, so here you have to draw highest lah, level of water, HP here. Okay, then the P definitely will be in between lah. Between them will be moderate velocity and pressure. Okay, so here will be the velocity I explained just now. Q will be have the highest speed, followed by R and P. So the pressure will be vice versa. So the pressure P is highest, will be showing the highest level water, which is HP, will be higher level, followed by R, then followed by Q. Okay, so the next will be, you can see now the difference between the first figure here, the second figure, sorry. Okay, so the second figure here, you can see the diameter at middle is wider. So just now we explained that when the tube with the narrower condition, so the speed will be the highest. So this will be the vice versa. So that means the Q will have a lower speed as the diameter is showing widest. Okay, so here, according to Bernoulli's principle, the pressure will be the highest. So we expected the water level will be the highest lah, for Q. Then again, for point P and R, which will be the lower, and which will be the highest? Since we have the lowest already, here will be the lower speed, so we need to define the highest. Okay, so here again, you can see the water from point P will be from smaller tube diameter to wider. So according to the hot tips we discussed just now, so the speed of the P will be higher than the R. So that means the P will have the highest speed, then the pressure P of water will be the lowest. Okay, so this will be in between. Okay, so let us see the discussion. Okay, so the middle part Q is widest, so the velocity will be the lowest, so the pressure will be highest at Q. Okay, so you have stated the velocity and pressure lah, so you can draw the water level correctly. Okay, so expected the highest lah, as I mentioned just now. Okay, then the comparison between P and R, just like I mentioned to you. So P, the water will be flowing from narrow area to wider area. So the speed will be highest lah, compared to R. Okay, so the pressure will be lowest. So the water level will be lowest lah, compared to others. Okay, so the R will be in between. Okay, so this will be the velocity comparison, just how we explained already. Okay, so the VQ will be the slowest, followed by R, and then P will be the fastest. So the pressure will be vice versa, and the level of water will be according to the water pressure. Okay, so now we continue with the A. Again, they will be the same. The first condition you can see here, the tube diameter will be narrow at the middle parts, just how we showing the flow of water. Okay, so actually we're using the same theory here. So here the narrowest, the speed of the A for Q will be the fastest. So the pressure, air pressure, now we discuss about the air pressure will be the lowest. So that means lowest, this is the air part. So the H will be here, will be showing very short to air region. Okay, so again, the air flowing point P here, so will be R. Now we compare. Okay, so since this is the highest, we have to find which is the slowest. So here, the P will be slowest because from wider diameter area to the smaller or narrow area. So the speed will be decreases. So here will be have the slowest speed of air. So the pressure air at point P will be the highest. So highest, again, I emphasize the H is from the parts of the air because now we discuss about the air pressure. Okay, so here, this is the water level. So the R will be in between. That means will be the moderate. Okay, so let us go through the discussion point. Okay, so here, the middle parts will be have the narrowest. So the velocity, okay, so the velocity will be okay, so the velocity here will be the highest. Okay, so I just saw that. So there is a lot of students here today. So welcome to my lesson of Putri, Alia. So welcome, Jimmy, Hao Feng. Okay, so thank you again. Okay, so for join my class. Okay, so and also my best partner, Cikgu Hasnitah. Thank you for join my lesson. Okay, so students, if I say you have any question, you can just let me know. Okay, thank you for your press from Jimmy. Okay, so hopefully you can follow me until the end of the lesson. Okay, so let us continue. Okay, so here you see the narrowest parts at the middle. So the speed of the air will be highest. So we'll be showing the lowest pressure. Here referring to air pressure. Okay, so here the HQ will be the shortest. So that means the water level will be highest. Okay, so this will be higher speed, lower pressure. Okay, again, you can see I already marked. So it'll be here. Okay, then the next here will be using the theory I explained just now. Okay, so when the fluid from larger diameter to smaller diameter, so the velocity will be decreases. And then the pressure will be increases. Okay, so here should be increases. Okay, so here got mistake already. Okay, so here is increases. Okay, so this one will be increases. Okay. Okay, so then here is what I label already. So since this is a lower speed, there will be highest pressure. So again, you must have higher HP from A because we discussed the flow of A. Okay, so the water level will be showing the lowest if I say you want to compare. Okay, so the next R point here will be moderate. So be at between P and Q. Okay. Okay, so then the speed I already compared just now. So Q will be have the highest speed, followed by point R and then point P. Okay, so the pressure here referring to air pressure will be vice versa. Okay, so here if I say some of the students will be confusing why just now I mentioned to you here the pressure is highest, so the water level why is shortest. Actually, is due to the lowest air pressure at Q. So this will be a lot more water to enter. So you can see the water level is showing highest. Okay. Okay, so the next will be again the same, but will be at A. So at the middle part, you can see the air is with the biggest diameter. So the velocity of air here will be actually the slowest lah. So when slowest, the pressure Q here will be the highest. So again, highest from air will be here. So the H, we need to refer to the air, not the water. So now is the A part. Okay, then again, second, you have to using the theory I explained to you. So this is, again, will be increase. Okay, so when fluid decreases, so you can see here, when the water flowing from narrow to wider, so the P speed will be smaller than Q, but smaller than R. So this is P, this is R. But definitely the slowest will be at Q lah. So that means here the speed of R will be the fastest. That means the pressure at R will be smallest. Here the pressure referring to A. So when the air pressure lowest, so here the HR will be the HR here is the smallest lah, but the water level will be the highest. Okay. Understand how you want, Okay, so okay, so thank you everyone for joining my lesson. Okay, so Jimmy and also the Kaizen. Okay, so let us go through the detail. Okay, so here the middle part of Q is the narrowest as mentioned just now. So the air velocity will be the highest. Sorry, here got mistake again. So the BM is correct. So here the speed is lowest. So here will be slowest. So the pressure will be highest. Okay, so here low velocity, high pressure. So here will be longest lah, the HQ. Okay, so thank you Jimmy also. Okay, so the next, so here will be have a higher velocity as we mentioned just now. So because the water, so the air is from narrow to wider. Okay, so be fastest. So P will be fastest than Q. Than R, sorry, than R. Okay, so here there will be with lower pressure. Okay, I think just now I reversed already. So this one supposed to be the correct one. Okay, so the R will be in between. Okay, so here comparison speed, Q will be the slowest, followed by R and P. So P actually will be faster compared to R. Okay, so P is faster. So according to what we learned just now here, this is increase again. Okay, so the highest air pressure at Q here will prevent or against the water to entering the tube. So the water level will be lower compared to others. Okay. Okay, so we have just finished learning standard 1. So we have another learning standard. So learning standard 2, here we want to discuss about the lift. So explain lift as a result of the difference in pressure due to the different velocity of fluid. Actually, just now we also indirectly discussed already. So when there is a difference in pressure because of the velocity difference, so the lift will be the force or resultant force we explained just now. Okay, so the force or net force will be moving from high pressure to low pressure. Okay, so this already discussed through the activity just now, the first one using the paper. Okay, so here will be to observe the effect of the lift force. Again, here we have the activity which is related to observe the effects of lift force. Okay, so here the first experiment or activity at the page 81 in your textbook. activity 2.14 will be fill the funnel with a ping pong ball. Okay, so here the procedure will be like this. Okay, so first, when the air is blow harder, so the ball does not fall down. Okay, so what is the statement here? So you can see this GIF. Okay, so the student is blow the filter funnel. So, and then you can see, so suppose the ping pong ball will be dropped due to the gravity. Okay, but you can see there is not. Okay, so this is due to the Bernoulli's principle. So because changes of the speed creating the difference in pressure, so the lift force will be formed. Okay, so here will be the discussion. Okay, so here, this because the air move at very high velocity. So you can see here when air is blowing, so the speed at region A and B will be higher. Okay, so this will be creating or producing the low pressure region. Oh, you see? So air moving very high velocity between the ball and the wall of the filter funnel. So they will be at the position A and B. So the pressure will become low. Okay, so here, according to Bernoulli's principle, so when the moving of air decreases, so the speed will be increases. Okay, so at region C will be here. Okay, so the atmospheric pressure in region C being higher than the air pressure in region A and B. So again here, you can see the pressure difference is produced. So C have a higher pressure. A and B, they will have a lower pressure. So lift force or the resultant force will be produced from the higher pressure to lower pressure. So the lift force will be produced with the red arrow here. So prevent the or against the gravity. Okay, so the lift force here will be greater than gravity. Okay, so the resultant force is produced upward and hold the ball, thus preventing the ping pong ball from falling down. So this is the first activity you can see at activity 2.14. Okay, then second, there will be an aerofoil or the aerofoil kit in your textbook. Okay, so the diagram will be show an aeroplane shape for cross-sectional area of the wing of aeroplane. Okay, so you can see here again, you can see one GIF. Okay, so you can see the aeroplane with the aerofoil shape of the wing. Okay, is moving up when there is a wind blowing in front. So this is the actually the wind direction indicator. Okay, so showing that the wind is blowing at this side. Okay, so the aerofoil is actually at the wing, at the wing of the aeroplane. Okay, so basically they will be like this shape now. Okay, so at the aerofoil shape of the wing, you can see that the path of air is longer over the upper surface than lower. You can see if we divide to two parts, so this will be the upper parts. So you can see the distance is longer compared to bottom. Okay, so for the wind from A point to B point, they will be reached at the same time. So for longer path, they must be moving faster compared to the shorter path. So we can conclude that. So the V or the speed will be highest, okay, at the upper region, upper surface of the wing. So they will be creating a lower pressure. Then the bottom parts, the air speed will be lower, so the pressure will be higher. So when there is a different pressure, so the lift force will produce from high pressure to low pressure. So that means the lift force will be moving up. Okay, so let us go to detail. Okay, so the lift is produced by the difference in pressure. So here, low pressure at upper surface, high pressure at lower surface. Okay, so here the force can be calculated by this formula. And this formula actually you learn also now, where the pressure equal to force over A. So the pressure here referring to different pressure. So that means you have to find P2 to minus P1. P2 will be here, highest pressure. P1 will be lower pressure. Divide. Okay, so no, multiply with area of surface, will be surface area of the wind. So you may get the lift force, and the calculation will be discussed at the question later on. Okay, so the next here will be another lift force is actually created with the aerofoil and different angle. Okay, so here at certain angle of attack, so aerofoil exerts a force on the air force. So that means besides the lift force we discussed just now, so there is an additional lift force because of the angle of attack. Okay, so what is the angle of attack? Okay, so angle of attack is the angle between the oncoming air. So you can see here, so this will be the airflow and the reference coastline on the airplane. So the coastline will be here. This angle will be the reference line we know as a chord line. And then this is the direction, motion of the air. So in between this, the angle we know as the angle of attack. Okay, so according to Newton's third law of motion, a reaction force acts on the wing of the plane. So this will be adding on the airplane. So here we have two lift forces. The first one will lift produced because of the pressure difference. This one we discussed already just now. Okay, so here the angle of attack will be producing another additional lift force. So we'll be showing by this smaller arrow. Okay, so this can be discussed by Newton's third law of motion. Okay, so this will be extra lift force for the aeroplane to lift up. Okay, so we go for our last learning standard. Okay, so the last learning standard here will be the communication about the application of Bernoulli'S principle in daily life. Okay, so here will be the application. So we know already the Bernoulli's principle basically will be discussed the relationship between the pressure and speed. As the speed of fluid increases, the pressure will be decreases. And the difference in pressure will be creating a lift force. So just now we explained already, so where the aeroplane can be fly because of the aerofoil shape of wing. Okay, so here we discuss more of that. Okay, so here again is the application of Bernoulli's principle. You may actually get the detail of the procedure and the textbook page 83, activity 2.15. There is a 4 application, and one of that we discussed already, where will be the aeroplane fly or creating the lift force by using the aerofoil shape of wings. Okay, so here will be another 3. Okay, so the first one will make sure the gas and the air in the Bunsen burner. Okay, so here you can see here we have 2 holes. The air hole is responsible to allowing the air entering the Bunsen burner. The second, there will be gas supply. So where is the fuse for burning? So here, how we can increase the efficiency for the gas and air mixed together in Bunsen burner. We know that the fuse need oxygen for combustion. So when we providing enough amount of oxygen, so the combustion will be completely. So we'll be given the blue color of flame. Okay, so how we can do that to increase the efficiency of the combustion? Okay, so this is related to the Bernoulli's principle. Okay, so the first you can see at the narrow outlet here. So this design of the outlet or the nozzle will cause the gas flowing at higher speed. So you can see here is connected to the gas supply. So that means here is related to the fuse lah. Okay, so will be moving at higher speed. Okay, so when this part moving at higher speed, so the pressure of the gas at the nozzle here become lower according to the Bernoulli's principle. Okay, then the next here will be the parts of the air. Okay, so here atmospheric pressure outside is higher. Okay, so when the nozzle parts pressure is lower, then the atmospheric pressure is higher. Okay, so the different pressure is produced and the force will be produced where to push the atmospheric pressure or the air outside into the Bunsen burner. Okay, so here at this part, the air mixed with the fuel gas completely. Okay, so this is applying of the Bernoulli's principle in the Bunsen burner. Okay, then the second, there will be the curved path of the football. So you can just look at the GIF. You can see the ball is moving. Curve is actually applying the Bernoulli's principle. Okay, so as the ball is moving forward, so you can see forward will be at this direction. Okay, so the ball spin and hence move the surrounding air. Okay, so you can see here, I using anti-clockwise because you can see the arrow, red arrow here. So the ball is moving in anti-clockwise. If I say clockwise, the direction will be opposite. Okay, so now I just discussed one of that. So you should know another rotation of the ball. Okay, so here we discuss about the anti-clockwise. So that means the ball moving here and here. Okay, so the direction of the air at the lower part. Okay, so here I already boxed with red color. Okay, so this will consider as a lower part. You can see when the ball moving forward, so the blue color line here will be showing the airflow. So the airflow will be at this position. And then the ball moving in this direction. Okay, I'm using different color. So you can see the blue arrow and the air arrow here is showing opposite direction. Okay, so when the direction of air is opposite direction with the spinning of ball, so the air speed will become slower, or here will be showing the lower speed. So when this is a slower speed at the bottom part, and the pressure will be higher. And the third point, here will be according to Bernoulli's principle, when the ball moving with the slower speed, so the pressure will be higher at the bottom part of ball. Okay, so here now we discuss about the upper part. Okay, so according to this arrow and the arrow of the wind, so you can see both ball and the air moving at the same direction or the similar direction. So the speed will become higher. So pressure will become lower lah. Okay, so you can look at the sentence here. While at the upper parts of the ball, okay, so the direction of the air is similar to the direction of the rotation of ball. Therefore, the airflow moves faster and the pressure is lower. Okay, so the lift force will be produced because of the difference in pressure, just like I mentioned to you already, right? So here with pressure will be lower at upper parts, then higher at lower parts. So that means the ball is actually will be moving outward. Here will be showing a curved path. Okay, so the last here will be the application in racing car before we go for the question discussion. Okay, so the racing car is actually using the same application of aerofoil, but here the aerofoil shape will be inverted. Okay, so in addition to use the airplane, okay, so aerofoil is also used in rising car. In this case, the aerofoil is inverted. Okay, so it's inverted. Then the inverted aerofoil is known as a spoiler. Okay, so you can see the shape is inverted. So the longer path will be at the bottom side. So that means the bottom side, the speed will be higher. Pressure will be lower lah. Then shorter path at the upper parts of the boiler will be at the slower speed, higher pressure. So again, we different in pressure, lift force will be produced, but the lift force here will be downward actually. So that means the force here is downward force. We not know as the lift force. Lift is going outward. Okay, so basically this is a theory you should know now. Okay, so number 2, air move with the higher speed at bottom, below the spoiler. I explained already. So creating a lower pressure. Okay, then for the upper parts, the velocity is lower, so the pressure will be higher. Okay, so this will be producing a downward force because of the difference in pressure. Okay, so the difference in pressure creating a downward force is very important for racing car because it may be give a stability and avoid a car from lifted or fall when moved at a higher velocity. Okay, so before we go for discussion or question, let us take a break first. And then we come back to with more example of question. Okay, so welcome back everyone. Okay, so this will be the first question. Actually, total we are going to discuss 3 questions. So 2 questions in paper 2, 1 question at section C. Okay, so the 2 questions in paper 2, section A, 1 question will be section C. Okay, so here actually is a conception question you will see at paper 2, section A, question number 5 and 6. Normally this will be 5 marks question. We compare reason with the comparison between 2 diagrams. Okay, so here diagram 5.1 shows a situation where the sheets of paper before and after blow will be this. And then the second diagram 5.2 will be the situation of canopy. Okay, before the car, the lorry move of before the lorry move will be this. And when the lorry move at higher speed will be this. Okay, so the question asks about the definition. This will be normally the first question now. So what is the speed? What is the meaning of the speed? So the speed is actually with the formula distance over time. So that means here will be rate change of distance because here is speed. If I say you give velocity, there will be different already. Okay, so here the answer here will be rate change of distance. Okay, So if I say using the displacement, they will be wrong because the speed is a scalar quantity. Okay, so the next here will be comparison between the diagram 5.1 and 5.2 here. Okay, so here you want to show two similarity between these two conditions. Okay, so the first one, you can actually look at the before air blow or the lorry is moving. So you can see the canopy is downward shape, right, due to the gravity. Okay, so there will be no any lift force before the air is blowing and together with the lorry is not moving. When the air is blown or the car is moving, here will be lorry. So the air will be flow, causes the speed of air higher and creating lower pressure region. Okay, so again, because of different pressure, there will be produce a lift. Okay, so the canopy will be lift up with this shape. Okay, so the similarity will be with two diagrams here. Okay, so the first, when air is not moving, paper and the canopy are not lifted, will be at the diagram 5.1 here. Okay, then the second mark, there will be when air is moving, so the paper and canopy are lifted. Okay, so this will be just observe the diagram. Okay, so the second question, we compare the air pressure above and below the paper. Okay, so the student, you may actually give your answer in chat room. Okay, so we can discuss together. Okay, so here again, the pressure, we need to know the velocity. Okay, so the paper, here when blow, so the speed will be higher, so the pressure will be low, right? So there will be vice versa at the bottom of paper. So when the velocity will be low, pressure will be high. So that means the pressure above will be lower than bottom. Okay, so pressure above will be lower than pressure below. So you can using mathematical symbol showing less than. Okay, so the third question here, we relate the speed of the air to the pressure. This one, you can actually just applying the Bernoulli's principle, right? So when the speed increases, pressure will be decreases or vice versa. Okay, so here, speed of air increases, pressure of air will be decreases. So this will be the answer for this question. Okay, so the next here will be name the principle involved in 5B3, the question just now. So you can see here, straight away, there will be Bernoulli's principle. So this is a subtopic we learned today. Okay, so the next question D. Okay, so this will be the observation by using also just now at the Learning Center 1. With the activity at textbook will be 2.13. Okay, so diagram 5.3 show an instrument used to measure the speed of the air. Okay, so when the level of the color water higher, right? Level water higher. So that means this will be pressure higher. So according to Bernoulli's principle, the speed of the air here will be lowest, right? Okay, so here we need to compare the speed at P and Q. Just how we also explained it. When there is a narrow region, so the speed of the air should be highest, right? Okay, so when this is higher speed, pressure will be lower. So we comparing the air, so here will be lower. Then here, the speed will be highest at Q, point Q here. Air will be lowest, so the pressure will be highest. So here will be, the water level will be showing actually lowest lah. But the air Q here will be greater than HP here. Okay, so here, just as I mentioned already, narrow tube, air speed will be high, pressure will be low at P. Then wider tube, so the speed of air will be low, pressure will be high. So for Q comparison, the speed, so definitely P will be higher than Q for speed. Okay, so speed of air P greater than Q. Okay, again you have to draw. Okay, you have to draw, mark the water level. So just like I mentioned to you, when we discuss about the air, you can draw air level first. So lower air will be here. Higher pressure of air will be here. Measure from air. So the water level will be showing vice versa. Showing opposite. Okay, so this should be the answer lah. Okay, so we mark here and here. Okay, so clear everyone. So this will be what we discussed already at Learning Standard 1. Okay, so we go to our second question. Okay, so here will be the past question 2017. Okay, so the diagram to show a cross-sectional area of spoiler. This one will be the application we learned at Learning Standard 3 just now. Okay, so which is attached to the rising car. The aerofoil shape of the spoiler produce downward force. Okay, this is actually the inverted aerofoil. Okay, just how we explained already. So name the principle involved in producing a downward force. Definitely here will be the Bernoulli's principle. Okay, so just now I just saw the reply from Jimmy, S over T. Okay, so here, correct lah, actually we better given the statement compared to using formula. Or Jimmy, if I say using symbol, you have to give what is terms of the S here should be distant. Then T will be the time. But we still advise students given the statement compared to formula lah. If I say you definitely, if I say you give symbol only, there will be no marks. If I say you give the formula for your definition, at least you stack your symbol, Jimmy. Okay, so here will be Bernoulli's principle. Okay, so the next question here will be B. Okay, so here will be the calculation where we want to use to find out the different pressure here. Okay, so the area of the upper surface of spoiler is with this value 0.25 meters square. So the pressure at upper parts of the spoiler so will be 1500 Pascal. So spoiler will be this shape. Sorry, you'll be reverse. So spoiler, the longer parts will be at the bottom. So here, upper parts, P equal to 1500. Lower parts will be 500. Okay, so the question asking you to find the difference in pressure. Okay, so what is the value for difference in pressure? Just now, we use the formula where we using higher pressure minus the lower pressure. Or here will be very directly, you can get from figure I draw already. So you just using 1500 to minus 500. Okay, so here answer is very clear that it will be 1000. So remember to give the correct unit. Without correct unit, the answer will be also considered wrong now. If I say you give 1000, they'll be wrong also. Okay, so there will be no any decimal places needed because this is exactly 1000 Pascal. Okay, so the second question here, the downward force adding on the spoiler due to the difference in pressure. Okay, so here we want to find, the force. Okay, so the force we are using formula we learned just now, right? So P equal to F over A. So the force will be P times A. So the P here referring to the different pressure lah. Okay, so here F equal to P times A. Okay, so the P here will be 1000. So A given by the question here, there will be 0.25. So with using unit SI, straight away we get Newton, which is the unit SI for the force also. Okay, then the next here will be the reason. Give one reason why downward force is very important for rising car, which is moving in higher speed. Okay, this one also you may get from our discussion just now. Okay, so this will be, you can see from the figure, so the downward force, F here will be increase the stability of the car by placing the car onto the road. Okay. Okay, so we go to our last question today. This will be the past question of 2021. So here will be a 20 marks question. And this here will be the section C multiplication question here. Together with 5 marks question comparison, which is a conception question. Okay, so diagram 11.1 shows the aerofoil board. So you can see the aerofoil board is here. Okay, that contains a surfboard with the aerofoil that is attached below it. So the aerofoil will be here. So when the board moves, the shape of aerofoil causes the board to lift it from the surface. You can see. So without aerofoil, the board will be at the surface of water. So with aerofoil, the surfboard will be able to leaving the surface of water. So that means here the friction of water can be reduced and the surfboard will be able to move more faster. Okay, so this will be the application of aerofoil at the surfboard here. Okay, so here will be also because of the Bernoulli's principle we learned already just now. Okay, so state the Bernoulli's principle. So Bernoulli's principle will be the relationship between the speed of the fluid and the pressure. So when speed increases, pressure will be decreases. So here will be the definition. So the speed of the moving fluid increases, the pressure will be decreases. So this will be the very straightforward principle and not very hard to memorize. Okay, so the second here will be the theory, 4 marks. Normally after the definition, they will be have the 4 marks theory. So here you have to explain how the aerofoil can cause the board to lift it when the board is moved forward. Okay, so here firstly, we know already, right? So we need to discuss the speed, upper parts of the aerofoil, and bottom parts of the aerofoil. So you can see the shape. The longer path will be at the upper parts. So that means the speed will be highest at the upper parts of the aerofoil. Then the pressure will be lower. Compared to the bottom parts, the speed will be lower, pressure will be higher. So the difference in pressure will be producing a lift force and cause the surfboard leaving the surface of the water, and the friction of water against the surface of the surfboard will decreases, and the surfboard may moving with higher speed. Okay, so here you need to give minimum 4 points, since this is a 4 marks here. Okay, so the first, we need to discuss the speed as per mentioned just now. So this will be the speed of water above increases. Then the pressure of the water below increases. So you can discuss one of the pressure. So you can discuss the pressure upper parts or the bottom parts of the aerofoil here. Okay, so here creating the pressure difference, just now also emphasized already. Okay, so this will be produce a lift force. This will be basically the 4 marks you suppose know how to write already. Okay, so the next here will be the lift force will be greater than weight. So the surfboard will be moving upward. Okay. Okay, then here will be the comparison question. Okay, so diagram 11.2 show the motorized surfboard without aerofoil in 5 seconds. Then the 11.3 will be the motorized surface with aerofoil, you can see. Okay, so the difference will be, you can see the surface of the surfboard is higher for diagram 11.3. Okay, so here will be the comparison. Firstly, you need to compare the height of surfboard. So definitely you can see 11.3 is higher than 11.2. So as per mentioned, when the surfboard is not touching the surface of water, definitely water friction for 11.3 will be smaller than 11.2. Okay, and then the next here will be relationship with the height and the friction. So the height increases when the water friction decreases. Okay, so 5 marks will be at 5 points. Okay, then the next here will be deduce the relationship between water surface, water friction and the speed. So when friction increases, the speed will be decreases. Okay, so we look at the answer together. So the first, as per mentioned, we need to compare the height. So here 11.3 is higher than 11.2. Okay, so first mark, height of surfboard 11.2 less than 11.3. So they will be as per what discussed just now. Second, we discussed about the water friction and the speed. Okay, so the water friction. So you can see in 11.2, the surfboard is touching the surface of water. Definitely friction for 11.2 greater than 11.3. See? So water friction added on the surfboard, there will be 11.2 greater than 11.3. Then the speed, definitely the 11.2 will be smaller than 11.3 because of the friction of water. So speed 11.2 smaller than 11.3. Okay. Okay, then the next, there will be relationship between the height of the surfboard with the friction. So height will be this. So height increases, friction decreases because the surfboard will be not touching the surface of water. Okay, so when no contact between two surfaces, the friction will be decreases. Okay, so height of the surface increases, frictional force will be decreases. Now here we're using water friction. Okay, so the last will be the relationship between friction and the speed. So the friction increase, speed will be decreases. You can see water friction decreases, speed will be increases. So that means it will be vice versa. Okay, so this will be the conception question for section C. Okay, so the last here will be the multiplication question. Okay, so let us go through together the question first. Okay, so diagram 11.4 shows the hydrofoil boat move in a seat. Will be just like figure 11.4. Okay, so you are required to design a hydrofoil boat that can be moved faster and carry more passenger at the same time and safely. Okay, so explain your suggestion based on the characteristic and size of boat. So you need to give 2 points here. One is a size, one is a characteristic of boat. So here got 2. Characteristic and size of the hydrofoil. So here is also 2. Power of engine use, 1 point here. then numbers of hydrophoid 1. So total you can write up to 6 plus 6. So the maximum marks will be 10. So that means here you can give minimum 5 plus 5. But I advise you give more than 5. Okay, because we're not sure that the characteristic you given is correct or not. But you cannot give contra answer. Okay, so the answer is advised in table form. Okay, it's in table form. Okay, so the firstly, just now we advised the first answer will be characteristic and the size of the boot. So the boot must be strong enough. So that means we're using strong boot, or you can using material, for example, steel boot. So reason, they will be not easily to broken and can use for longer time. Okay, so this will be a suggested answer. So the characteristic here, you can give the strong boots or steel boots. So reason, they will be not break easily, no leakage, or strong or durable. So this will be the reason for the first suggestion. Okay, so this will be the first. Second, you can give the size of the boots. Since the question asks for carry more passenger, so therefore we need to have a bigger size lah. Okay, so the bigger size, that means the volume is bigger. So with formula, buoyant force will be related to rho Vg. So when V increases, where the size of boot increases, it will be given greater buoyant force, because the displacement of water is more because of this formula. Okay. Okay, then the next, you can discuss about the characteristic and the size of the hydrophoid. Okay, so the characteristic, again, you can using same suggestion answer in the first one, where related to the boots. So the hydrophoid, we also can actually using strong hydrophoid, steel hydrophoid with the same reason. Okay, so here I showing another characteristic. So where we can using low density. Okay, so the characteristic of the boot, you also can using low density of boots lah. Then the reason here also the same, with a lower mass, so the boots will be more easily to accelerate. Okay, so this answer can also use for the characteristic of the boots. So the characteristic of the boots also can be applied for the characteristic of the hydrophoid in this question. Okay. Okay, then the next here will be the power engine. Definitely we want to have the higher engine. Okay, so here will be high or larger. High or larger. Okay, so reason, with the higher power, so the higher force can be produced lah. Then the last here, we can discuss about the numbers of hydrophoid. You can look at the figure showing 2 hydrophoid. That means here, the suggestion will be more than 2. Or you can just give the numbers of hydrophoid must be more. Okay, so why? When there is more hydrophoid, so the lifted force will be actually greater. Okay, so here, the force produced will be higher or more power. So definitely when moving higher position, so here will be related to the buoyant force will be greater. Okay, so here actually the more related they will be, the lift force will be more actually. Okay. Okay, so I think that is all about the discussion today. Okay, so thank you everyone who is joining my class today. So before our class, I would like to share you the link for the e-schedule. Okay, so you may actually fill out within the 30 minutes after the class end for today's. Okay, so thank you for everyone. So please click like and share my lesson today for your friends, so that more of your friends can get the benefit from my sharing today. Okay, and then don't forget to follow the next physics classes. So where the Form 4 Physics will be at every Friday, 9:30 p.m. And again, the Form 5 class will be as usual, Sunday, 8:45 p.m. Okay, so that's all for my sharing today. So bye-bye and see you again. Okay, bye-bye.